So this is from 4.1. Find the particular solution to dy dx equals 3x squared minus 1 using the initial condition when x is 2, y is 4. Or they may state it like this, capital F of 2 equals 4. We did this back in section 4.1. Okay. This is called a differential equation. It's a differential equation because it's dy dx. It's an equation that has been differentiated, if you want to think about it like that. How do you undo differentiation?
You got to find the integral.
You got to find the antiderivative or the integral. You remember this?
Yes.
So first thing you really got to do is move the dx over. So write this as dy equals 3x squared minus 1 times dx. Okay. Right, Gabe?
Yes, sir. Sorry.
Now we have to take the integral of both sides. We have to find the antiderivative. The antiderivative of dy, which is y, (3x squared minus 1 dx). That's pretty easy integral. Just take the integral of each separate piece. What's the integral of 3x squared? It's 3x to the third over 3, but the 3's would cancel, so it's just x cubed. And then the integral of negative 1 is negative x. And then, since this is an indefinite integral, we add a plus c. Now, normally, we would just leave it as plus c. The plus c is just the constant of integration. But they've given us an initial condition so that we can find the value of c. Okay? The initial condition is, you guys ready?
Yeah.
The initial condition is when you plug 2 into capital F, and capital F is the antiderivative.
Mm-hmm.
Where's the antiderivative? What am I talking about for antiderivative?
The integrated solution.
That's the antiderivative, right? This initial condition is saying when you plug a 2 into the antiderivative, it equals 4. Remember doing problems like this?
Yes.
Yeah.
So 4 is equal to 2 cubed minus 2 plus c. You plug in the initial condition into the antiderivative.
It's kind of like finding y intercept.
Yep.
Just trying to find that in you.
Happy for you. Happy for you.
You guys with me? 2 cubed is 8 minus 2. 6. Subtract 6 from 4.
Negative 2.
You get c equals negative 2. So now your antiderivative turns into x to the third minus x minus 2. Okay? There's two different words here in terms of terminology that you need to be aware of. This right here, with the constant of integration, that's called a general solution.
Perfect C.
That is really perfect. C.
Like that C is literally flawless.
This right here
Like Beyonce.
is called a particular solution.
Beyonce, child.
That's a Beyonce of C's.
Okay? We got to keep this moving, you guys. We got to keep this moving.
Token credit. Perfect credit. I'm not hot on politics right now.
You got it? This is old stuff that we've seen before. In chapter 6, it's not that much different. Or at least in 6.1, it's not that much different. Okay? Let's just take a look at an example. They get a little more complicated in 6.1
Okay.
in terms of what your differential equation looks like.
Sir.
So write that down. Y double prime subtract y equals 0.
Whoa.
Okay? You know this notation. What does double prime mean?
We don't know
Second
yet.
derivative.
Second derivative. So you guys, not that it's super important,
Looks like
but they would call this a second order differential
expression.
equation. They would call this a second order. Okay? Why second order, do you think? Because it's a second derivative. If this had just been y prime minus y, they would have called that a first order differential. You see what's going on there? Anyway, that's not super important, but you might see this phrase in the homework, so you need to know what they're talking about. Okay? Your homework starts with a problem like this. Verify
Doesn't that mean they equal each other?
y double prime minus y equals, they equal each other because it equals 0 when you
Yeah.
subtract. Yeah. So you would be given a problem like this. Verify that y equals 4e to the negative x. Is a solution. Verify that y equals 4e to the negative x is a solution to the differential equation.
I thought we were double.
So we've got to figure out two things. We've got to figure out y double prime, and well, I guess we already know y. So we really only need to figure out one thing. What's y double prime? So if y equals 4e to the negative x, what's y prime? And then what's y double prime?
To the negative, it's negative 4e to the negative x. And then that'd be
You guys with it?
negative, that'd be 4e to the negative x.
Say that again, Braden.
Well, the first derivative will be negative 4e to the negative x. And then the second derivative would be 4e to the negative x.
You guys understand how he's getting this, right?
Oh yeah.
Yeah.
The second derivative would be the derivative of the first derivative, which is 4e to the negative x. So this is y double prime. This is y. If we take 4e to the negative x and subtract 4e to the negative x, isn't that the same as y double prime subtract y?
Correct.
And what does it equal? If you take something from itself, you get 0.
So we verified.
So we verified it. Okay, so one of the solutions to this differential equation is 4e to the negative x. That's one of the solutions. Okay. Part B. What about y equals sine of x? Is that a solution to the same differential equation? Y double prime minus y
It's not.
with that. I don't know. What about y equals sine of x? Try it on your paper. See if you can.
I just did it in my head.
Did it in my head.
Oh wait, no, it isn't.
It's not because you get negative sign, which you
Yeah.
get, which you get 2 cents.
But the fourth derivative would.
Amen.
Heck yeah.
Oh, that's all we think about here. Derivatives. Excitement.
Darn it.
Yeah. What's the first derivative?
Cosine.
Cosine of x. But what's the second derivative?
Negative sign.
What's the derivative?
So if we do y double prime subtract y, we get negative sine of x minus sine of x, which is not equal to 0, which it should.
That's weird.
So this is not a solution.
Sorry, I love you to scratch out.
Okay? And as a matter of fact, this is what most of the homework is. They give you a differential equation. They give you a potential solution. You've got to verify that it is or that it is not a solution. Let's try another one.
Yes, sir. Thank you for your support.
Example 2.
Number 2.
Oh,
The next section is when you actually learn how to find the solution on your own without having been given the solution.
That was a great section.
is that for me?
For me.
She's not here.
Okay.
Okay, the differential equation is y prime equals 2xy divided by,
3
holy moly.
You really.
This is jacked up.
Why don't you use a hard one? You should have.
That's shady.
Verify, here it comes, verify that x squared plus y squared equals cy.
So we have to take the integral of this. Right?
Okay, for real.
Really? Okay.
Wait, was that wrong?
What do you guys think?
I think we're gonna take the integral of this.
That's c times y. What are we gonna have to do on this problem?
Take the integral.
I don't know, but I can't straight.
Because you have to have c. So we have to take the integral to get a constant, right?
Good job.
You have to,
I mean, you have to
you
add
have to
in
get
some-
the second derivative, and you also have to get y. Like you're only given y prime.
So we don't need the second derivative.
Okay, hold on. Shh, shh, shh. Think about what we did on the first example. Did we have to do anything really with the differential equation?
No.
No, we had to mess around with this potential solution. We had to mess around with the solution to verify that it was equal to the differential equation.
Right?
So we're not going to have to mess around with this differential equation. We've got to somehow mess around with this potential solution and see if we can get that equal to this differential equation. You guys follow? So what can we do with this to make it look like that? You can take a derivative.
That's what I would do.
Okay. You guys following?
But then, isn't that going to be implicit though?
No. Yes.
But that works. Because that would just be q over dx.
Which is the same as y
But then
prime.
when we have a dc over dx?
What?
C represents a constant, it's a number, not a variable. Okay, you guys, watching somebody else do everything isn't a good way to really learn stuff. Okay, you know what it is you need to know. There's not any really new techniques. I want you to try something on this.
Just getting the group
Okay.
to happen.
Try something on this one.
All right, guys.
Okay?
I'll take a
And
chance.
if it doesn't work, erase it and try something else. But you're not going to be able on the AP test wait for somebody else to give you hints or ideas. You've got to come up with your own ideas.
I hate that failure feeling you get when you do
Okay?
wrong.
But it's just life.
Okay, so C, the constant. C.
Let's actually go back up here.
Wait, I'm almost done.
Hold on, let's go back up. If you still have room, add a part C to that first example. If you have room somewhere. So, let's use the first differential equation we had. What was it? Y double prime subtract y
Yeah, I don't pay attention.
equals 0. What if we verified that y equals c e to the x? Let's try it on the one we just did. Verify that y equals c to the x is a solution. So we're going back to the first differential equation we had, the y double prime.
If you think 4 is the same.
So what's y prime?
c e dx.
C e to the x.
That's also a double.
And then y double prime.
c e dx.
So did the c really have anything to do with it in this problem?
No, sir.
Wait, but wouldn't that make y prime work also?
Yeah, but they're just interested in y double prime subtract y. That's the
Because-
differential equation.
Because can't C be -1?
C could be anything.
But I was just wondering, so if it was like y double prime or y single prime minus y equals 0,
Still work.
you're
It still works.
verifying that.
But we need to verify it's a solution to this differential equation, so we had to find the double derivative for the second derivative.
Yeah.
Okay? So y double prime subtract y is equal to c e to the x minus c e to the x, which is 0. So the c really didn't matter in that. Okay? Hey, what's up? Alright, where did we get to?
Differentiated.
Okay, well why don't we try this? Can we take x squared plus y squared equals c to the y, divide both sides by c.
I'm gonna move this down. Let's do a few more that involve C to see if we can get a little more comfortable with it.
I'm trying to, I just want to figure out this much Jiva.
We will. We've got 15 minutes. We'll do it. So let's try xy prime. Those are really easy. xy prime minus 3y equals 0.
Y prime?
xy prime minus 3y equals 0. We'll finish it in just a sec. Let's do a few more that involve C.
Is this kind of like the identities? Like we're trying to manipulate the equation to make it so that...
For trig identities?
Yeah, like when we were trying to... Well, trig, yeah, where we were trying to like make one side equal the other side.
Possibly.
It's kind
You
of like
can
that.
think about it that way. Okay. We know that y equals cx to the third. What's y prime?
Y prime would be
3
3cx squared.
cx squared. Right?
Yeah.
So if we take this y and we take this y prime and plug it into the differential equation, what should it equal?
0.
Should equal 0.
So y.
So we have x times 3cx squared minus 3 times
cx cubed
cx cubed.
equals 0. So we can solve for x now?
No, we don't need to solve for x because we just needed to show that this minus this was equal to 0. This is x times y prime and this is minus 3y, and what does it equal?
Because you can multiply the x.
The x makes that into x cubed,
Okay.
and this is 3x cubed times c, so it does equal
Yeah.
0. Okay?
I don't know.
But there's a little addition. Now, find the particular solution. Remember, a particular solution has to have initial condition. For y equals 2 when x equals... They want to find now a particular solution. Y equals 2, x equals negative 3. See, the problem is y equals cx to the third. That's a general solution. Because what could c be?
Anything.
Anything. So they want to find a particular solution so we can find an exact value of c, which would be one of the particular solutions. So we know that y equals what? What was it? Cx cubed? Is that what it was?
Cubed, yeah.
We know this is a general solution.
So we plug in a 2 for y and a 3.
Exactly. Well, first of all, how do we know it's a general solution?
Because it's said.
Because when we plugged it into the differential equation, it equaled what it was supposed to equal, 0, right? If you plug in a negative 3 for x and a positive 2 for y, negative 27,
Yeah.
divide that over, so c equals 2,
27.
negative 2 27ths, right?
Yes.
So a particular solution would be y equals negative 2 27ths, x cubed.
Oh.
That's a particular solution. Okay. Let's do one more quick one, then we'll get to that one we were working on.
Someone's giving me a hard time game the one time I said
I'm so much.
You do a trig one.
I'm a premature giant. I'm about to those jokes, like about politics and stuff. See those? I don't know which one I am.
What the heck?
But
I saw that. I was
I
like,
hate 300.
That's either y to the 1,111 power,
Then it's
or that's a
little
fourth derivative.
laugh at it.
Personally, I just think y got over points.
I don't really respond to mature.
He just needs one
16
more cross.
pi.
If you were to do it to the fifth derivative, would you put the cross line?
No, they actually go like this. They would do it like that.
Ooh, they got bored.
No, they need to do it like the boxes. When you do counting the boxes.
Tally ho.
No, that's where it would get confusing. So, y, that's not y to the fourth power. That's y
The fourth derivative.
fourth derivative. It's y quadruple prime. That's how they would write it. So y equals 2 sine x.
We already found this out.
See if it's a solution. It's a different differential equation now. It's y quadruple prime minus 16y.
Did we go,
Yeah,
Gabe?
yeah.
You wish.
It's just immaturity. And I only respond to maturity. That's how mature I am. I'm like a big great grandfather chair. Come on.
So, okay.
Okay, so y equals 2 sine prime, 2 sine x. Okay, so it's just 2 cosine x, then it's negative 2 sine x. Then it's 2 sine, negative 2 sine x, and then it's
Put the work down. Put the work down. Instead of trying to do it in your head.
oh,
Put the work on the paper.
dang it. Is that what we're gonna need for the AP test?
Yeah, you've got to get used to showing your work.
Such a bother though.
Indeed. Oh yeah, it turns into 2 sine x. That's what I said earlier. Get me unsure. Take that up in hand.
It equals 2 sine of x. Oh, what?
Y equals 2 sine of x minus 16 sine of x. Why do I feel like 2 sine of x minus 16?
So, the question here isn't verify, it's to determine. This might not be a solution.
Oh, I don't think so.
The question is determined, so this is a yes or no.
I'd say no.
I'd say also say no.
I don't feel like that would equal 0.
It wouldn't.
You're going no?
No, I just have a
It
look
equals the same exact thing as y, so you can't just, it's like saying y minus 16y equals 0. That just never will work.
That's so foolhardy to say.
So, what's y prime?
Hey
It's 2
man,
sine x.
No, it's fine.
Oh, I thought I was just thinking y.
And then double prime?
negative 2 sine x.
And then triple prime?
Negative 2 cosine x.
Cosine x.
And finally,
2 sine x.
Sine x. Right where we started.
so, if we have y quadruple prime is 2 sine x, and we subtract 16 of what y is,
2 sine x.
and y is 2 sine x, does this equal or not equal 0?
Oh no.
It's
So-
approximately
It's
0.
Not a solution.
I think I figured out
Oh
how to do
no.
Well, it depends, because we have to know what
My
x is.
colleagues laugh about that all the time. So I figured combine from all the
Because if x is 0, it's still 1.
or not.
Let's get back to that problem we were working on.
Okay.
Just talk to Mr. Cooper about it.
I tried dividing by c and then taking the derivative.
It was x squared plus y squared equals cy,
I learned this last thing in English.
What'd you learn?
and the differential equation was
Thousands.
y prime.
2xy over x squared.
No, it was actually like
Okay. What do you guys think? Verify. So it's implied that this is a solution. We just got to verify it. Okay. Conversation's not important right now. This one is.
We said the two y prime.
What do you mean?
So I differentiated and I got.
You differentiated which one?
The one on the right.
With respect to x?
Yeah.
With respect to x, yeah. So with respect to x, so y prime. What if we want to know if dy dx equals,
Which is y.
Which is the same as y.
which is y prime equals 2x over c minus 2y. Couldn't you just replace that y prime with the solution? Because that's isn't that what we're trying to do?
So you got
2x
2x.
over c minus 2y.
well,
Equals y prime, that's, if you differentiate, that's what
what's the derivative of y squared?
2y.
2y dy dx.
And then what's the derivative of this?
c dy dx.
C dy dx. So then you minus 2y
So you
over.
divide both sides. Well, divide both sides.
You minus 2y over and then you divide.
Yeah, you subtract 2y over it and then you divide by 2y.
2y and c, leaving just dy dx.
We want to get the dy dx on the same side,
Which
right?
is, yeah, after you minus 2y dy.
So you're going to have 2y dy dx minus c dy dx equals 2x. This is implicit differentiation, right? Okay. So you factored out dy dx, which is really just y prime. Okay. And then what?
2x.
Factor out a y prime.
Oh, I use 2y minus c. Equals negative 2x. And you divide. Both sides by that.
And then you got the negative.
Oops. It would be negative 2x over.
2y.
Yeah, that's what I got. So I got positive 2x over c minus 2x. So. Formalities.
Times it by negative 1. So,
So then that's what we got, and that's not it. So it doesn't work.
wouldn't you plug that then into y prime? Then set the two equal, like have them equal each other and then
We debunked it.
okay, no, I just was trying to get ideas.
So this is what I mean. You have to try something. If it doesn't work, that means we need to try something
Well,
else.
I did that way, and then I tried at the very beginning doing dividing by c. So y is by itself on the right side.
Okay, hold on. We have another idea. You divide it by c,
Yeah.
like that.
Yeah. And then I did the closure rule, but I don't think that works with the constant.
Yeah, you would need to do a closure rule.
So yeah, that was.
Okay. Did anybody try anything
I
else?
just debunked myself. Did you divide by y? Do it that way? Probably no. Never mind.
And get c by itself?
Yeah, that doesn't make any sense.
Wait. So x squared over y plus,
Y squared over y.
which is just,
Y.
is equal to c. Now what if we differentiated this with respect to
C.
X.
Oh, with respect to x. So you'd have to do a closure rule, not first rule.
so d over dx
So you got low d high y times 2x all minus
minus high
dy dx all over y squared
plus
y prime all equals dy dx y prime.
what's the derivative? Hold on. What's the derivative of c? Okay, you guys, we're gonna have to finish this, but look at what happened.
You have to second.
Look at what happened when we tried tried this way, we still had C in there, right? And we didn't want C in there because that's screwing things up. But if we divided by y and got C by itself and then took the derivative,
Oh, my brain is awesome.
what happened to C? What's the derivative of C?
0. Yes, that's,
0.
that is exactly right.
Okay, so we're going to have to move some things around here, but this is the direction we've got
Okay,
ahead.
that makes sense now. Holy crap. The other one is
Good job, Kate.
Great job, kid.
Kate, you should take the AP test. No, I don't have knowledge.